continuing with the identities, with more identities in trigonometry, and specifically we are now going to continue with the double angle formulae. This is a continuation from the compound angle formulae. Now the double angle for cos 2a. So remember from the compound angle formula for addition of two angles in a cos, we had, if you have cos a plus b, we say this would be cos a cos b minus sine a sine b, right? This is what we had. Now if you have cos a plus a, this is going to be cos a minus sine a sine a. So here we have cos, this now we call it 2a, so cos 2a is going to be cos squared a minus sine squared a. So this is the double angle formula for cos 2a, and this is very important. It's a very important part of trigonometry. So from what you can see, we keep building the concepts from the smaller things as we go on. So now we have, this is cos 2a is equals to this. Now this is the first version. We can have another version. So no, this is another version from this same equation, the second version. So we've said cos 2a is equals to cos squared a minus sine squared a. But remember, we said cos squared a plus sine squared a is equals to 1. So we can choose to start by making cos squared the subject. So cos squared a is equals to 1 minus sine squared a. So we can come and say cos 2a would be equal to 1 minus sine squared a minus sine squared a, such that we have cos 2a is equals to 1 minus 2 sine squared a. So we have this. So this is another version. Now all these equations are very important. So we have this is another version. Then we can have another one, version 3. And now how are we going to get version 3? We're just going to use the same expression. If we make sine squared a the subject, what do we have? We shall end up having 1 minus cos squared a. So we substitute it here because we're saying cos 2a is equals to cos squared a minus sine squared a. So if we say this is now going to be equals to cos squared a minus 1 minus cos squared a. So we have cos 2a is going to be equal to this becomes cos squared a minus 1 plus cos squared a. So what we have? We have cos 2a is going to be 2 cos squared a minus 1. So we have this. So now we can we have these two. Now we can try to make sine squared the subject here so that we can have another expression. So here, if you make sine squared a the subject, you're going to have cos. So you're going to have 1 minus, because this will come this side, this will go that side, 1 minus cos 2a. And here I have. Then here, if you try to make cos squared the subject, you're going to have cos 2a plus 1 into a half. So we're going to have this. So this is also another expression that we've generated from the same. So now you see we have this. So what was I saying? I was saying that all these are coming from just knowing the compound angle formula for cos 2a. So you realize you don't have to necessarily maybe cram, or let's say have all these in your head. You just have to have this. So you just have to have the compound angle formula, then all this can be derived from that, and they're going to help you in different instances in solving different questions. Now we're going to look at the double angle of sine 2a. So we're first going to say it was a compound angle for sine a plus b. We said this was sine a cos b plus sine b cos A. Then you come and say, how about if we have sine A plus A? This is going to be sine A cos A plus sine B, sine A, because this time it's both A, cos A. So this becomes sine 2A is equals to 2 sine A cos A. So this is the double angle formula for sine 2A. Then the double angle formula for tan 2A. So we're going to recall that when we had tan A plus B, this was tan A plus tan B out of 1 minus tan A, tan B. We're going to have about tan A plus A. This is going to be tan A plus tan A out of 1 minus tan A, tan A. So now we get tan 2A is going to be equal to 2 tan A out of 1 minus tan squared A. This is the compound angle formula for tan 2A. So now let's move on. Now the summary of the double angle formulae. So the first one we saw for cos 2A is equals to cos squared A minus sine squared A. And we also saw cos 2A, and I showed you how we derived this. Cos 2A is equals to 2 cos squared A minus 1. Also cos 2A is equals to 1 minus 2 sine squared A. All these are very important, as we're going to see. Then how about sine 2A? Sine 2A is going to be 2 sine A cos A. How about tan 2A? Tan 2A is going to be 2 tan A. So why am I emphasizing these things? So in case you're solving any question and you land on anything like maybe tan 2 theta, sine 2 theta, it's going to be okay for us to just substitute this. That's why I said it's important for us to remember these. Now we're going to look at something called the half angle formula. Now this is alright. Now we're going to look at the half angle formula. We're going to look at the half angle formula for cos A. So we should first remember that the compound angle formula for addition of two angles in a cos was, so be cos A cos B minus sine A sine B. So how about if we have cos A? So what the half angle formula, if we have cos A, believe cos A can be the same as cos A out of 2 plus A out of 2, because this is the same as that. So now we can expand. This will be cos A out of 2 cos A out of 2 minus sine A out of 2 sine A out of 2. So here we get cos A is equals to cos squared A out of 2 minus sine squared A out of 2. Now, as we said last time, that from the double angle formula, we can always generate more other formulas from this. So here, let me put here this. Then I can say, but remember, cos squared A out of 2 plus sine squared A out of 2 is 1. So if I make cos squared A out of 2 the subject, I get 1 minus sine squared A out of 2. So if I substitute that here, I get cos A would be equals to 1 minus sine squared A out of 2 minus sine squared A out of 2. So that means cos A is equals to 1 minus 2 sine squared A out of 2. This is another one. And you can even go ahead and make sine squared A out of 2 the subject. And this would be, because this would go this way, so we'd have 1 minus cos A. And here I would put a half. So then we can come, then we also say again, remember, cos squared A out of 2 plus sine squared A out of 2 is equals to 1. This time I make sine squared A out of 2 the subject to be 1 minus cos squared A out of 2. So if I substitute into this formula, I would get cos A is equals to cos squared A out of 2, minus 1 minus cos squared A out of 2. So when you open the bracket, this will become a plus. So we end up having cos of A equals to 2 cos squared A out of 2 minus 1. So you see we have 3. We can also make sign the cos squared A out of 2 the subject here, such that we have this is equals to cos A plus 1 to a half. Now these are going to be very important in proofs and even in solving different equations. Okay. Then now we look at the half angle formula for sine A. So we first remember that what was the compound angle formula for addition of two angles in a sine? It was sine. So it'll be sine A cos B plus cos A sine plus cos A sine B. So now how about sine A? This can be sine A out of 2 plus A out of 2. So this becomes sine A out of 2 cos A out of 2 plus plus cos A out of 2 sine A out of 2. So we have sine A is going to be 2 sine A out of 2 cos A out of 2. So this is the half angle formula for sine A. Then we'll go to the half angle formula for tan A. So you remember what was tan A plus B. This was tan A plus tan B out of 1 minus tan A tan B. So we say tan A is going to be the same as tan A out of 2 plus A out of 2. So this is equals to tan A out of 2 plus tan A out of 2 out of 1 minus tan A out of 2 tan A out of 2. So this means tan A is going to be equals to 2 tan A out of 2 out of 1 minus tan squared A out of 2. So this is the angle formula for tan A. This. Alright, then now we have the triple angle formula for cos 3A. Now for the triple angle formula, I'm not going to do all of it, but I want to give us a clue and then I just keep pausing the video to solve. So here, if we have cos 3A, we're going to break it down into cos 2A plus A. Then from the here we have this is cos 3A is equals to cos 2A plus A. So when open, this will be cos 2A cos A minus sine 2A sine A. Now the goal is, since this is cos, we are going to want to express our answer, or like the product this side, in terms of cos. So that's why this expression cos 2A, there are very many ways it can be expanded. It can be expanded to be 1 minus 2 sine squared A, or it can be expanded to be cos squared A minus sine squared A, or it can be expanded to 2 cos squared A minus 1. Now that's the one I'm going to choose because since this is cos, we want to express things this side also in terms of cos. Okay, so now we have this. We're going to expand this to be 2 cos squared A minus 1 into cos A minus, now the sine 2A has only one we can expand it. This is 2 sine A cos A to sine A. So we have open this bracket. This is 2 cos cubed A minus cos A minus 2 sine squared A cos A. Now we have this is 2 cos cubed A minus cos A minus 2. We now expand this to be 1 minus cos squared A. Hope you know where that's coming from. It's coming from that identity of cos squared plus sine squared is 1. So I just make sine squared the subject. Sine squared will be 1 minus cos squared. That's how I got that. Is equals to 2 cos cubed A minus cos A minus 2 cos A. This now becomes plus 2 cos cubed A. This becomes 4 cos cubed A minus 3 cos A. This is the triple angle formula for cos 3A. So I just wanted to show us that when you're dealing with the triple angle formula, you try to express the things on the right hand side to be, since this is cos, we try to express everything here in terms of cos. So that's the same thing when we are doing the one for sine, we try to express everything in terms of sine. So sine 3a is going to be equals to sine 2a plus a. When you expand this will be sine 2a cos a plus cos 2a sine a. This will be 2 sine a cos a into cos a plus this. Now we're going to want to use this expression for sine, because I told you since this is sine I want everything to change to sine. So when you open this bracket, this will be 2 sine a cos squared a plus sine a minus 2 sine cubed a. So even here, this is 2 sine a, this is 1 minus sine squared a plus sine a minus 2 sine cubed a. Now we can finally open this bracket. This is 2 sine a minus 2 sine cubed a plus sine a minus 2 sine cubed a. So this is 2 plus comes 3 sine a minus 4 sine cubed a. So this is what I get, sine 3a is equals to that. This is the triple angle formula for this. Now why am I doing this here? Because as we're solving some numbers, we're going to find instances where the question in the middle, maybe we find something like sine 3a. I'll just quote it because I have expected that we showed the working here, and also it's good for the practice. Then now here we have the half angle formula for tan 3a. Now this is going to be somehow long because this is tan 3a. It's going to be tan 2a plus a. So this is tan 2a plus tan a out of 1 minus tan 2a tan a. So now these are the double angle formulas. We're just going to substitute. This is 2 tan a out of 1 minus tan squared a. Now if you didn't master that, you could actually just do it on your side work and no one will penalize you for that. Here we have 1 minus still 2 tan a out of 1 minus tan squared a into tan a. So what do I multiply both up and down by 1 minus. I see here, this everything here, I multiply it by, because there are very many. Some other person would choose to use LCM, you would still come up with the same answer, but because I don't have so much space, I'm trying to work with what I have. So you do this. Now when you do this, this will multiply, it will cancel. That's why we get 2 tan a plus tan a into 1 minus tan squared a. Then down here, for 1 will become 1 minus tan squared a. Then it should be minus 2 tan squared a, since this will cancel with that. So now I can continue from the side here. This will be equals to 2 tan a plus tan a minus tan cubed a out of 1 minus 3 tan squared a. So this is tan 3a and this is tan 3a. So what is tan 3a finally? Tan 3a is 3 tan a minus tan cubed, so tan cubed a out of 1 minus 3 tan squared a. So if, let's say, just to make it simple, if we replace t with t, if we let t to be tan, not tan theta, tan a, that means we can have the tan 3 theta. I don't know why I'm confusing it. Tan 3a is going to be 3t minus t cubed out of 1 minus 3t squared. So this is the angle formula for tan 3a, triple angle formula for tan 3a. So now I think that's going to be it. Now we can have the quadrangle formula, but for these I'm just going to pause and work it out after this, so I believe you can follow through. So this is the quadrangle formula for cos 4a. So as you can see, you break it, cos 4a is equals to cos 2a plus 2a, you expand this, then as you expand this, as you try to substitute, you always try to use expressions that have cos in them. So here, that's why I say this is 2 cos squared a minus 1, then 2 cos squared a minus 1. You expand both of these, and eventually came up with this. Now let's look at quadrangle formula for sine 4. So I'm going to pause and do the same thing, and you can actually also try to do it to see if you follow. Okay, so this is for sine 4a. So sine 4, this is equals to sine 2a and plus 2a. So we expand same thing, but we give preference to those expressions that contain sine. But you see, it was impossible to eliminate cos. That's why it's, but some cos stayed, but still, that's it. Okay. Now this is looking for the quadrangle of tan 4a. So let me do the same thing. Okay, so this is the solution. You can actually continue from here and find the value of tan 4a, but this was just actually mostly practice. But the questions that will come, they'll ask you to prove that tan 4a is this, for sine 4a is. Now let's look at this proof. It's going to be an application of what we've been covering so far. The question says, if A, B, and C are angles of a triangle, prove that this is equals to that. Now the first thing we should do is to draw a triangle here. So if these are angles of a triangle, let's say this is A, it's angle A, this is angle B, this is angle C. You see? So this is angle A, angle B, angle C. Now what are we going to do? We're going to know that angles of a triangle, let me even write it, angles of a triangle must add up to 180. You see? Now here I see tans, so I'm going to say tan of A plus B plus C must be equal to the tan of 180. So then here, remember we said if we have something like this, we just break it down into two. See? What's the tan of 180? It's 0. So now we expand. This is tan A plus tan B plus C out of 1 minus tan A tan B plus C is equals to 0. We cross multiply, so that will go with that. So we'll end up having tan A plus tan B plus C will be equals to 0. So now I can say this is tan A plus, now I expand this, tan B plus C out of 1 minus tan B tan C. So now let's continue here. So this is equals to 0. So I can choose to multiply through by that. Let me write it here. Multiply through by 1 minus tan B tan C. You see? So here what will I have? I'll have 1 minus tan B tan C into tan A plus tan B. Oh, sorry, this is plus tan C plus tan B plus tan C is equals to 0. Then I expand this bracket. This is going to be tan A minus tan B minus tan A tan B tan C plus tan B plus tan C is equals to 0. So now I just take this term, the other side, so I'll have tan A plus tan B plus tan C is equals to tan A tan B tan C. So just like that, we've proved this.